So let's talk about machine learning. You hear the term everywhere, and it can sound, well, pretty complicated, right? But what if I told you it's not some unknowable black box? We're about to demystify the whole thing, and by the end of this, you'll have a clear map of the entire landscape.
All right, let's just rip the Band-Aid off and ask the biggest question right up front. How does machine actually learn anything? It feels like magic, but I promise you it's not. It's a process, a set of rules and ideas, and we're going to break it down piece by piece. I want you to think about this like we're explorers heading into a vast new world. And what's the first thing any good explorer needs? A map. That's exactly what we're going to do right now. Together, we're going to draw that map, starting with the giant continents. So here we go. We're starting at the highest possible level, the main types of learning. Think of these as the absolute foundations of our map, the continents where all the other details live.
First up, we have what's called supervised learning. And honestly, the best way to think about this is like studying with an answer key. You give the machine a bunch of problems, like thousands of pictures of animals. But, and this is the key, you also give it the answers, telling it, this one's a cat, that one's a dog, this one's a bird. The machine just crunches through all those examples until it learns the patterns on its own. Okay, so what happens when you don't have an answer key? Well, that's where unsupervised learning comes in. This time, you just dump a massive pile of data in front of the algorithm and basically say, go find something interesting. It has no pre-existing labels. It just has to look for natural patterns and structures all by itself, grouping similar things together.
And you probably saw this coming. There's a really clever middle ground called semi-supervised learning. It's the best of both worlds. You give the algorithm just a tiny bit of labeled data, just a little hint, and it uses that clue to figure out a huge amount of unlabeled data. It's super efficient. And you've probably seen this in action without even realizing it. Think about Google Photos. First, it does the unsupervised part. It scans all your pictures and automatically groups similar faces together. It doesn't know who they are, it just knows they look the same. Then you step in. You look at one of those groups and type in a name, like mom. That one little label is the supervised part. And bam, the service instantly applies that mom label to all the other photos in the group it already made. That's semi-supervised learning right there. Our last big continent is reinforcement learning, and this one is a totally different beast. Here, there's no giant data set to study. Instead, you have an agent, like an AI playing a video game. It learns by pure trial and error. It takes an action, and if it's a good move, it gets a reward, a point. If it's a bad move, it gets a penalty. After doing this millions or even billions of times, it eventually teaches itself the best possible strategy to win. DeepMind's AlphaGo, which taught itself to beat the world's best Go players, is the most famous example of this. It's learning by doing. Okay, now that we have our continents mapped out, let's zoom in. We're going to start in the world of supervised learning, and our first stop is a country called regression. This is the land of predicting numbers. The whole point of regression is to predict a number that can fall anywhere along a continuous scale. The question it answers is always how much or how many. You know, how much will this house sell for next year? What's the temperature going to be tomorrow at noon? What will this stock be worth in 6 months? If the answer is a specific number, it's almost certainly a regression task. And to solve these how much problems, data scientists have a whole toolkit of different algorithms. You've got things like linear regression, decision trees, and random forests. Now, you don't need to worry about how they all work right now. Just know that each one is a different tool designed for the job of finding that final number. The toolbox is full. Now, this is a really important distinction to make inside supervised learning. Because if regression is all about asking how much, its sibling, classification, asks a totally different question. It asks, which one? So let's travel to that other country, the land of classification. We're leaving the world of numbers behind. Here, the entire goal is to sort things into neat, separate buckets or categories. So with classification, the model takes some kind of input, maybe it's an email or a photo or a financial transaction, and its only job is to assign it a label from a predefined list. The classic, everyday example is your spam filter. Every single email that comes in is either spam or not spam. There's no in between. It's one or the other. That's classification. And here's the toolkit for classification. But wait a second. Does anything on that list look familiar? Yep. You're seeing decision trees, k-nearest neighbors, and random forests again. That's because some of these algorithms are incredibly versatile. They're like Swiss Army knives. They can be adapted to either predict a number or pick a category. Which brings us to a special little region on our map. Let's talk about these algorithm all-stars, the powerful, flexible tools that show up for work whether the job is predicting numbers or sorting categories. So here they are, the big four. K-nearest neighbors basically works on peer pressure. It just looks at the closest neighbors to a data point to make its decision. Decision trees are like a giant game of 20 questions, following a flowchart down to an answer. Support vector machines are masters at drawing lines, finding the best possible boundary to separate different groups. And my personal favorite, random forest, is all about the wisdom of the crowd. It builds hundreds of different decision trees and then makes them all vote on the final answer. Pretty cool, huh? All right, let's pack our bags and leave the land of supervised learning. We're now heading deep into the unsupervised continent, and our main destination is a place called clustering. This is the art of finding groups you never knew existed. At its heart, clustering is really simple. It's about putting similar things together. But here's the twist. The algorithm has absolutely no idea what the groups are supposed to be. It just looks at all the raw data and figures out for itself which points seem to naturally belong together. You can think of it as automatic organization. And there are two main flavors of this. Hierarchical clustering is cool because it builds a kind of family tree, showing how small clusters of data merge into bigger and bigger ones. Non-hierarchical is more direct. You just tell it, hey, find me 5 groups in this data, and it does its best to sort everything into exactly 5 buckets. For our last stop on this grand tour, I want to pop the hood open and look at one final, really important concept. We've talked about all these algorithms, but how do we actually control them and fine-tune them? The answer is something called a hyperparameter. Now, don't let the fancy name scare you. It's just a setting that you, the human, have to decide on before the training even starts. Think of it like the knobs and dials on the outside of the machine. The model learns the patterns inside from the data, but the hyperparameters are what control how that learning process happens in the first place. And this makes it crystal clear. Remember when we said with clustering, you might tell it to find 5 groups? Well, that number 5, often called K, is a hyperparameter. Or in the K-nearest neighbors algorithm, how many neighbors should it look at? That K is also a hyperparameter. How many trees should you build in a random forest? You guessed it, that's a hyperparameter too. Choosing these settings is a huge part of making machine learning work well. And there you have it, from the main continents of learning to the specific tasks like regression and classification, and even a peek at the knobs and dials that tune the whole thing. We've drawn our map of the machine learning world. It's not so scary now, is it? So the only real question left is, now that you have the map, where are you going to explore next?